it going? This is Chris. I wanted to talk a little bit about YAABE, which is yet another Atom BIOS editor. Again, that is yet another Atom BIOS editor. It's like the ultimate AMD ATI Radeon graphics BIOS editor. And you can create SPPTs with it, soft powerplay tables. It's what we've always been dreaming of. And I've been messing around with it for the last couple of years, and it's been awesome. This is a 6950 XT reference VBIOS here, and I'm going to go through some changes we can make to this VBIOS to enhance the performance and the thermals on it. What I would do first is change the MVDD ratio, set that to 0, which will change the observable voltage of the MVDDC, the memory module voltage. It will change the observable memory module voltage, but it's not so much a telemetry as much as it is a ratio. If we set it to 0, we can run ultra low voltage at idle, all the way down to as low as 900 millivolts, rather than 1000 millivolts is what the stock is. So that's pretty sweet. We can run it down to 900 at idle. I think you might be able to run it down below that even. I think actually you can run below that. You can run it down all the way down to 675 millivolts at idle with the MVDD ratio at 0. And you're going to want to change the boot up MVDDC to 1000, because with the change of the ratio, the 1350 will be way too hot at 0 MVDD ratio. So I've observed that through testing, through experience, that you want to set this to 1000 maximum on desktop graphic cards, and on a laptop you're going to want to stick around 900 if you set the MVDD ratio to 0. 900 maximum on laptops and 1000 on desktops, but you can push it a little bit, 1100 maybe, 1150, but 1000 really I feel like I can achieve peak performance on the memory at 1000 millivolts with the MVDD ratio at 0. Okay, so this is the boot up MVDDC, so we would change this under Atom firmware info 3, version 3.4, and change the boot up memory voltage to 1000 and the MVDD ratio to 0. And then we're going to come right back up here to the ITC control. This is the temperature sensors and stuff. We can observe the graphics core temperature and hotspot. We can observe this is actually the voltage. So we can observe the core voltage. We can observe the SOC voltage. We cannot observe the VDDCI or MVDDC. So as you can see here, 224 is a slave address on SOC and GFX. So what we do is change the VDDCI and MVDD to 224 slave address, and you're good to go at that point. Just change the slave address on these two to 224 to observe the voltage. No, this is not voltage. This is actually temperature sensor. My bad. This is going to be the temperature. And so this is GFX SOC VDDCI MVDDC. We can observe the temperature of the VDDCI MVDDC. By stock, you cannot observe it. So this is important. And then we can get down here to the PLX. This is the PCIe components on the board, which typically aren't cooled. So it's important to observe the temperature of these as well. So I would set this to 1. Make sure that you look here at the ITC controller speed. It's fast. The port 0 thermal throttler anyway. Come back on down here because so we set it to. Speed fast, which is number 1, right here. Speed fast, but I'm going to leave that back. So where was that? It's fine. I'm not going to save this BIOS. I'm just showing you what to change. Set this to 1. Set this to speed fast. Set the slave address to 224 here. Set the ITC controller to the, if only I could see, but it's not GFX, it's going to be PLX. So. We need to fix this. There it is. 7 is PLX. And then set the ITC controller protocol to 1, which is IR35217. International rectifier IR35217. Okay, so we're good there. That's temperatures. So we can observe every sensor on the board. And then let's jump on down to spread spectrum. It looks like we can achieve a 331 megahertz. At any given frequency the car is going to be running at, we could potentially achieve up to a 31 megahertz overclock. At any given frequency the card was going to run out stock, it's going to run 31 megahertz higher if by setting this to 0. So setting the PLL, the phase locked loop for the GFX SOC to 0, the digital frequency locked loop DFLL to 0, we can achieve a free 31 megahertz overclock. Even though it's not enabled, I'm sure it does have an effect on it because I've seen people have a delta between their operational and their set frequency. UCLK, I would recommend setting this to 0, 0, 0. So 0, 0, 0, 0, 0. And for the FCLK 0, that's going to be the Infinity Fabric. Or, yeah, Infinity Fabric. So, now let's move on down to, let's move on down, all the way down. This is stuff that's outside of the PowerPoint table, which I've referred to at this time. So let's refer to everything outside of the PowerPoint table first. And then let's move on down to the Atom Voltage Objects Info version 4.1. And then this is for the GFX core. What I always do is set this to 0, 0x00, loadline PSI, which will permit the core to run precisely at the voltage at which is desired by the user, and not different. Wouldn't you much rather see it running at the voltage that you set it to, or would you rather run at a different voltage as what you set it to? Of course, I think the majority of people would say they would prefer for the card to run at the voltage they set it to run at, not different. So by setting this to 0x00, loadline PSI will permit that. And I do that to the VDDGFX VDDC VDDCI MVDDC, and that's it. So that's outside of the powerplay table. Now let's take a look at the powerplay table and see what we can do with it. First thing I do is change this to 88, the software shutdown temperature. 88 rather than 118. I mean, I would never want my baby running beyond 100 degrees Celsius. I mean, this is a $500 piece of hardware in 2026. The RX 6950 XT reference, which is such a beautiful card. I would never want to run it beyond 100. So I'm going to set this shutdown to 88. I don't know why people think they do run their cards hotter. Hotter is not faster. I've tested this with 26 years of with almost, let me think, I'm 38. For 30 years I've been testing computer programming and testing hardware. And for 30 years I've tested that the peak performance a card can yield is nowhere beyond 84 degrees Celsius. And I set it to 83 so that it can run up to 83.9 and might spill over to 84. Because if you set it to 84, it'll spill over to 85. And it's optimal to run it below 84. So, okay, so we'll set the shutdown at 88. And then platform caps. This is nothing in here that was to be messed with. At this time, at least. I mean, there's nothing in here. Okay, so then we got the power saving clock modes, maximum. We can set here the everything on the card, every clock. And I'm sure that we can even overclock the ray tracing clock. It's probably some sort of clock domain which controls the ray tracing. And I'm sure I could figure it out eventually to improve the ray tracing performance on RDNA 2. And then hopefully AMD will listen and improve it, and improve upon it, which they have through the years. Anyway, because of my overclock.net experience and reputation. So we got this right now. The card's going to do 2719 megahertz stock peak. That's all it's going to do. And we can set it to even higher. I would probably set this right here to 1200 to give it 2400 on the memory, and give it a 1-to-1 between the SOC and the memory clock. That would be optimal, I think, to run 1-to-1 between the SOC and the UCFK. It looks like you can overclock the Infinity Fabric. Everything else here is not, I don't know. This is all like encoder stuff and display pixel clocks and stuff like that. So I'm not sure how they're handling the ray tracing engine on RDNA 2, if it's all handled by the core, raw power of the core, or if it's handled by a domain. A clock domain, like FCOK or something. I don't think so. I think it's all pre-handled. Well, Arduino 2 does have the FCOK, the Infinity Fabric clock. I haven't seen that on Arduino 1, I don't think. I could check it later. If I remember seeing FCOK on Arduino 1. I don't remember, I'll have to check. Anyway, we can turn this up if we want later on, I will. And we'll test it. And then let's move on down to Overdrive settings max. It looks like they've already got it set up to run at 5,000 megahertz at 1500 billion volts. Is that? No. Yeah, 5,000 megahertz is the peak, so you can push it to 5,000 if desired through LM2 operations. It looks like there's a custom curve here. I'm learning myself. This is the first time I've actually looked at this before, so I'm learning about Arduino 2. So it looks like we've got a custom curve here at the VFT, which is probably going to be the 5,000 again, 5,000 megahertz. Clearly, looks like you can overclock the memory up to 3,000 megahertz. Power limit, we can increase that to 100% if we desire. I will probably mess with that. I'm hoping the card can do more than 3,300 RPM, but I'll have to test to see what the peak RPM is on the card first before deploying an increase in the VBIOS. As far as the target temperature would go, I would obviously set those lower. 100 to 110 is too hot for me. I would have something minimum. Looks like they don't have the voltage like they did on the Arduino 1 curve. So that's nice. It's nice to have it a little bit simpler. Supported power savings modes, power mode settings, acoustic, temperature limits and stuff like that. That's pretty sweet. Oh cool, you can change the power limit. So this is actually defining the parameters of, for instance, quiet mode, balance mode, turbo mode, and rage mode, which is pretty damn sweet. It just is like straight up, you can program everything in this YAABE, which is so awesome. You just have to know what you're doing a little bit with your experience. You have to test it yourself. And throughout the years, I've been messing with this for like 5 years, maybe something like that. It's been awesome the whole time. I'm loving it. I love editing using yet another Atom BIOS editor / Atom BIOS editor. This is like what AMD engineers use, which is awesome. ATI technologies and such. Okay, so we can change all that stuff. You can change the operational RPM of the fan and such, which is cool, in the power mode settings. Undefined. Okay. Now let's take a look at the SMCP table. There's nothing here to mess with, but we could mess with the infrastructure limits for sure. Alright, according to what I understand, PPT1 is going to be the voltage, because that's the peak voltage, is 1200 millivolts. We can adjust that. We can set it to any desired value, which is sweet. We can increase the power line here. You always want to set it to 1-to-1 between the. I always do, at least. There's no point in setting it any differently than that. It's best to just set everything 1-to-1 between the power limit and the ampere limit on the TDC. So set this to whatever you want. I haven't tested the card yet. I gotta mod it out first before I start pushing it, because I'm certainly not going to run the card up to 100 degrees Celsius core and 110 degrees Celsius hotspot, or run the memory up to 100 degrees Celsius, or run the voltage regulator of the GFX core up to 115 degrees Celsius, or run the voltage regulator of the memory up to 115, or anything, or the SOC, or the PLX, which is set. I'm changing all these to 83 degrees Celsius. Every one of them. And then let's take a look at this SMN CLK DPO. It looks like this is controlling V droop. I would probably just set this to 0. Zero it out, I think. I'll test that later on. And then the thermal control mask, we're good there. Actually, we want to set the, after setting the temperature of the PLX under infrastructure limits, we will set the temp PLX to 1. That will also prevent the PLX to be observable under HWF. And then let's take a look at voltage control, ULV settings. We can set the core minimum to 675 like RDNA 1. No problem. Just set that to set this to 0 for the ULV voltage offset GFX. Set that to 0 and then set the minimum ULV to 675. Might as well save some power, but I'm not going to because I'm looking for peak performance. I think that I'm going to save some power regardless, but might as well set it to 675 so it can operate most efficiently. Let's take a look at voltage parameters. Minimum voltage GFX. I'm going to set that to 675. I might increase the max voltage of the GFX depending on if I have the headroom available. I'm going to set the load line resistance on the GFX and SOC to 255.996 milliamps, which can only be achieved if setting the load line resistance to 256. Because if you try entering 255.996, it will just default to a lower value. The peak value, which would be 256, which would default to 255.996 milliamps. Anyway, moving on. Temp VBID. This is nothing. Well, huh. This is pretty interesting. I might mess with this later on to see what it does. It has something to do with, obviously, throttling or something, but this is minimum. So it'll force it to run at a lower frequency, probably helping it save power on multi-monitor configurations. And then let's take the DPM config, GFX. What I would do here is set this to 0, 0, 0, 0, 0. That's for the slow cell curve. It's unnecessary, especially, it is necessary for stock configuration. But if we want peak performance, we will set this to 0, the conversion to AVFS CLK M to 0, and the SS curve ABC to 0, as well as the SS F min to 0 as well. What is that? F min for SS curve. This is spread spectrum curve. If the spread spectrum curve is selected, we'll use V voltage at spread spectrum F min for F min. Okay, well 0. Anyway, frequency tables. We would just set this to whatever we desire it to be set to. Later on, I'll get into that. Especially with the CUCLK, we would set this to 1200. We have to change it 3 different places. If you want to change the frequency, you can change it first here in power saving clock modes, and then you have to change it again and frequency tables here. So there's 2 places, 1200 here, whatever I desire here. I might be able to get it up over 3 gigabits. That'd be awesome. I might be able to. And then change it here as well. DC mode. Switch that and switch this. Voltage. Memory voltage. Remember when I said earlier about the MVDD ratio? How by stock the value is 1,000, which changes the observable temperature and voltage of the card. Well, it doesn't change the observable voltage, it does change the temperature by setting the MVDD ratio from 1,000 to 0. It does definitely increase the temperature, which tells me it's providing more power to the chip. So we want to set these down to 1,000 for peak performance. You're going to want to cool the memory controller on the PCB. We'll look at that later, as far as where to cool what and whatnot. We'll set all these to 1,000. Okay, now let's take a look at GFX SOC. This is very important right here. This is peak, like, if you want the card to run at a static frequency, this is where it's at right here. But you have to be very, very careful to set this frequency here on all 3 of these to a frequency at which you are damn well certain that the voltage at which you set up here and voltage per amps, make sure that that's 1200. You know that this frequency you're going to set here is stable at that voltage, very stable. Or else as soon as you deploy it, the more power tool and reset the driver, it's going to black screen on you. And and then you're gonna have to get into safe mode, pull up more power tool, delete the soft power plug cable, restart, you're good to go again. But you're gonna want to make sure you set this up correctly, and the benefit of it is well worth it, because we can achieve a static frequency under gaming load. So we don't have to, it doesn't have to fluctuate all over the place. We can set it to achieve 3 gigahertz all day long by setting these to 3000. By adjusting the spread spectrum at the beginning up here, as I explained earlier, this is outside of the power play table, so this must be flashed. We're zeroing out these. You can get, you're not going to quite get 3000 out of it, even at that. I don't think, at least. I have to test it because I haven't even got the card yet. I'm preparing before I got the card. Now, 31 megahertz offset delta between operation and set. So if you set 3000, it could be running like 2,998, which still, makes me, you know, I hate that, honestly. So what I would set it to is like 3005 to make sure that it achieves, or 3007 to make sure it achieves at least 3 gigahertz operational, and that just shows the full 3000 megahertz. Take a look here, nothing important. Flops, quick light. That's pretty interesting, I don't know. Quick light table? It's a table, so interesting. You see, okay, DPM, nothing changed here. Late DPM, nothing changed here. Fan control. What I would do is set these to, actually just ignore these fan stop parameters. If you want the card to slowly transition to full speed, set the fan gain to 400. But if you want to be at the top of the charts on 3D Mark, you're going to want to set this to 65,535 on all of these fan gain values, so that at the precise moment that the card goes under load, it will instantly go to full speed without any delay at all. And the second you leave load, will it go to back down to idle. But that's only for benchmarking. And then whenever you want for gaming, for general gaming, 400 is pretty good. For just your general quiet gaming session. PWM bin, it looks like it is 3,300 maximum RPMs on those deltas. For the reference 6950 XT. I would set this to 3,300. So set the fan acoustic limit to 3,300. Well, depends on, if I'm gonna be on a benchmark, I want to set the fan acoustic limit to 3,300 and the throttling RPM at 3,300 and the max RPM at 3,300. And leave the fan minimum PWM. So that way it won't have an acoustic threshold any longer. It will go instantly to full speed. But I would have to set the target temperature here to 60. so that it will target a 60C edge core tip, so that as to keep the hotspot in check. We will set this to 60. Everything else looks fine there, except for the fact that we will disable the zero pad. Let's take a look at the AVFS. Looks like they did the right thing and zeroed it out for the most part. We could disable the PLL by setting this to zeros. And if you have a delta between your set voltage and the observable voltage in AMD Radeon settings tuning, then what you do is you set it to the volt. I don't think it's going to matter on RDNA 2, but on RDNA 1, you had to set the voltage to 850, zero out all the GFX related content under AVFS curve, and the DC PTC mid-backs here, we would set to 0. And often, well, always, after deploying the said BIOS through more power tool as SPPT, would there be like a offset from the core voltage to the set voltage of around, depending on what your voltage is set up, anywhere between 30 and 130. So you might have to zero these out. Zero out the DC BTC max, especially with the zeroed out slow soak curve, which will permit a higher performance clock. And it's going to yield more performance, that's for damn sure. Okay, so that's it. That's it. Nothing else. Actually, there is something else. Let's take a look at this precise, piecewise linear group. And so this is the V group. We don't have to worry about V group if the VRM load line PSI is set to 0.0. I mean, it's going to droop, but it's going to be just fine, because if we're compensating for V droop, you're just going to pick up more thermals than is necessary. So I feel I'm going to zero out all these V droop values and parameters and let it run, let it droop all day, let it do its droop. It's got to droop. The V droop occurs anyway with the heating of the electronical components, the power components which power the GPU in the first place. The V droop occurs because the phases aren't cooled, and they just keep getting hotter and hotter, and the droop gives more and more. Same with the capacitor, the electronic capacitor. As the capacitor heats up, the resistance becomes, pretty sure it actually becomes greater. Don't hold me to that. I'm not an electronic specialist or anything like that, but I do have a lot of experience. Anyway, I hope you all enjoyed this video. This is awesome. This is the yet another Atom BIOS editor on GitHub by Netblock. You did a great job, and hope you all are enjoying your weekend. I love you all so much, and I'll talk to you later. Bye-bye.